Our last problem is a problem involving a projectile, and projectiles obey the equation negative 16t squared plus 800t plus 600. Well, the 800 is specific to the problem. The 800 is what we call the initial velocity, and the 600 is the initial height. So that can vary, for each problem. So if we shoot a projectile up with initial velocity of 800 feet per second and initial height of 600 feet, we can calculate the formula for the projectile. In general, the formula is going to be S of t is going to be negative 16t squared plus v naught t plus s naught, where v naught is your initial velocity and s naught is your initial displacement, or your height. Now that's if you're using the English system. If you're using the metric system, your equation becomes negative 4.9 t squared plus v naught t plus s naught, where the measurement of s is in meters. So let's take a look at our problem, and our problem says we got S of t is equal to negative 16t squared plus 800t plus 6,000. What is S of 0? If we plug in 0 where the t is, we're going to get negative 16 times 0 plus 800 times 0 plus 600, which equals 600. So S of 0 is the displacement of the projectile at time 0. That means we're shooting it up from a height of 600 feet, perhaps from a cliff or a high hill of some sort, or a building. But we're shooting the projectile up from an initial height of 600 feet. We want to find the time at which the projectile reaches the maximum height. So let's go back to the equation. All right, this is a quadratic function again, and it opens down because the coefficient of t squared is negative 16. Because it opens down, the vertex is a maximum. To find the vertex, we use negative b over 2a. So we use negative 800 over 2a, negative 32. Divide 800 by 32. (800) divided by 32 is 25. Now 25 is going to be the time at which the projectile reaches the maximum height. To figure out what the maximum height is, we've got to substitute 25 in for t, and so we get negative 16 times 25 squared plus 800 times 25 plus 600. So we rewrite that, negative 16 times 25 squared plus 800 times 25 plus 600. And the answer comes out to be 10,600. So the maximum height is going to be 10,600. The last question is, when does it strike the ground? Well, when it strikes the ground, what's going to be true about the height of the projectile? It should be 0. So we need to solve the equation, negative 16t squared plus 800t plus 600 equals 0. Now to solve that, we're going to use the quadratic formula, or we could factor it. Let's see, we could divide by 4, and we can have negative 4t squared plus 200t plus 150, right? Is equal to 0. Now we can also divide by 2, and if we divide by 2, we get negative 2t squared plus 100t plus 75 is equal to 0. Now we can use the quadratic formula to solve for t. So using the quadratic formula, we have t equals the opposite of b, negative 100, plus minus the square root of b squared, which is 100 squared, minus 4, a times c. Negative 2 times 75 is negative 150. All divided by 2a is negative 4. So let's evaluate the discriminant, stuff underneath the radical. So we're going to get 100 squared plus 600. So we have 100 squared plus 600. Okay, that's 10,600. Take the square root of that, about 102.96. Let's store that. Store that in x. Okay, if we store that, okay, then we have negative 100 plus the stored value and divide by negative 4. So one t value is going to be negative 0.739. Now the other t value is going to be negative 100 minus x divided by negative 4, 50.739. So which answer makes the most sense? Obviously you can't have negative time, so when it hits the ground it's going to be 50.739 seconds. If we round that off to the nearest hundred, it'll be 50.74 seconds.